So first we talked about nominal GDP, that is, GDP not adjusted for changes in prices. Now we're going to talk about real GDP. So the issue with nominal GDP is that it, as I said, it does not control for changes in prices. So you can imagine that if the price of every good doubled, then GDP would double. And this is the case even though the production of goods and services has stayed the same. So if we want GDP to be a measure of how much stuff we're making in the economy or how much stuff is being bought and sold, well then not controlling for these changes in prices is bad. And so this is where real GDP comes in. So it corrects for changes in prices. And so we're going to talk about two ways of doing this. So one, the simpler one, is what's called real GDP at constant prices. So in this case, GDP is determined as if prices haven't changed since some base year. So that is, we're keeping prices fixed at the level they were in some given year, and then we're allowing the amount produced or the amount consumed to change with each subsequent year. So put another way, since we're weighting the production by their prices, we're not letting those weights change as we move from one year to the next. The other way is chain-weighted GDP, which in a sense uses a rolling base year. And this is the method that you'll find is used by most rich countries. So when Canada calculates GDP, real GDP, this is the preferred measure. Likewise with the United States. And what's important is that these methods are different. They're going to give different results. And so therefore the choice is going to matter, maybe not a lot, but it will matter for the results you get, for how much, say, real GDP changes between 2 years. So let's start with a simple example looking at using base year prices to calculate real GDP. So here's our fictional economy. So we have 3 years, and the economy makes only apples and oranges. So we can calculate nominal GDP in each year, which is just the sum of the production of both goods weighted by their prices. Or put another way, it's how much was spent on apples in a given year plus how much was spent on oranges in that year. And so you can see here you have nominal GDP in 2002, in 2003, and in 2004. And then we can use these values to calculate the growth rate of nominal GDP between any 2 years. And so this is the formula here for the growth rate. So it's the change in GDP from one year to the next divided by GDP in the original year. Or you can rearrange that to be GDP in t plus 1 divided by GDP in period t minus 1. They're the same thing. And doing that gives you the following rates of growth. Between 2002 and 2003, according to this, GDP, or nominal GDP, grew at almost 125%. And this is the case even though, going back, you can see that the amount produced did not more than double for these goods, right? A growth rate of 100% would mean that it doubled, the production doubled. Now, evidently the production did not double, and so the reason why this growth rate is so high is because prices also changed substantially. Likewise between 2003 and 2004. So what about real GDP at constant prices? So i.e. the base year method. And so we're going to start with a base year of 2002. So what does that mean? It means we're going to take the prices of these goods from 2002, and when we calculate the GDP in all subsequent years, so in 2003 and in 2004, we're going to pretend that the prices of those goods didn't change. So if we do that, real GDP in 2002 is the same as nominal GDP because the prices, the weights we're assigning to these two levels of production are the same, both in the real and the nominal calculation. The real GDP in 2003, so here you'll notice that we've replaced the prices in 2003 with the prices from 2002. And so that gives us a real GDP in 2003 of $176. And doing the same thing in 2004, we get a real GDP of $228. We could do this again if our base year was 2003. In this case, we're picking the prices of 2003 and assigning them or acting as if those were the prices that prevailed in 2002 and in 2004. And so again, this will give us results for real GDP in all years. And we can do the exact same thing with 2004 prices. So in that case, the base year would be 2004. Now, notice that this leads to different results for the growth rate of real GDP in each year. So using 2002 as the base year, we get a growth rate between 2002 and 2003 of 35%. If the base year is 2003, we get a real GDP growth rate of 31%. And if the base year is 2004, we get 33%. So your choice of base year matters. It matters for the estimated growth rate of real GDP. Now, obviously, it doesn't matter that much. I mean, the difference between 31 and 35 isn't that great, but certainly it does matter. And so why does it matter? Well, remember that when we're calculating GDP, what we're doing is we're summing up the production of all these different kinds of goods, so in this case, apples and oranges, and we're weighting them by their respective prices. So the higher is the price of a good, the higher is the weight we're assigning to it in GDP. And so that means that when relative prices change, that changes the weights we're assigning to these different goods. So that's what I have here in this bullet point. So I say the relative prices of goods are different between the base years. So if we're using 2002, the relative price of apples to oranges is 1.25. But if we're using 2003, the relative price of apples to oranges is 0.78. So that means that if we're using 2003 base prices, we're valuing apples less than if we're using 2002 base prices, because the price of apples relative to oranges is lower in 2003. So we're valuing apples less in 2003 than we are in 2002. So I say here, if the relative prices of the goods remain the same, then the real GDP growth rates would be the same. And as an exercise, should you wish to do it, assume that the prices of both goods increased by 25% from 2002 to 2003 and by 60% from 2003 to 2004. So that means that the ratio of the two prices won't change. They'll both have increased by the same amount, but their ratio is unchanged. Using these same quantities, recreate the table from the previous slide. You'll find in this case that because the relative prices haven't changed, it won't matter which base year you use. So because the choice of base year matters, that's why we developed chain-weighted real GDP. So the changes in the relative prices of goods are usually small for consecutive years, right? So we saw that our choice of base year didn't matter that much. However, over many years, the changes can be substantial. And so here as an example, I give the relative price of computers and other consumer electronics. When computers were sort of first brought into the marketplace, they were incredibly expensive. Now, they're far, far less expensive relative to other goods. And so your choice of base year, when you're looking at the GDP contribution of the production of computers, is incredibly important. One will, if you used, for example, the prices of computers in 1980 to calculate the GDP contribution of computers today, that would be a huge contribution. Absolutely massive. And so for this reason, most countries have started using an alternate scheme, which is called chain weighting. And so we'll see how this works. So to calculate the chain-weighted real GDP growth rate between two consecutive years, we first calculate the real GDP growth rate using both years as base year. So in other words, we do what we did before. We calculate real GDP for both years, and we're going to do it twice. So we're going to calculate real GDP for both years using 2002 prices, or that is using 2002 as the base year. And then we're going to do it again using 2003 as the base year. And then we're going to figure out what the growth rate of real GDP was in both of those cases. So that's what we do here. So this first one is First, calculate real GDP in both years, 2002 and 2003, using 2002 as the base year, and figure out what the rate of real GDP growth is. And so in that case, it was 1.354, or 35%. Then, do the same thing using 2003 prices. So find out what the growth rate of real GDP was between 2002 and 2003 when you use 2003 as the base year. And in this case, you get 1.312 or 31%. Then what we do is we take the geometric average of these two growth rates. So the geometric average means multiply them together and take the square root. So in a sense, we're getting an average growth rate. So we're taking those two growth rates, 1.354 and 1.312, multiplying them together and taking the square root, which gives us a growth rate somewhere in between, so 33%. Then we can use that growth rate. So this was a calculation for growth rates. We then use that growth rate to figure out what real GDP was in both years in their respective dollars. So for example, the real GDP in 2003 in 2002 dollars is we take the GDP in 2002, multiply it by our measured growth rate to get the value of real GDP in 2003 of $2002, or in $2002. Going the other way, maybe we want the real GDP of 2002 in $2003. Well, in that case, we would divide by the growth rate. We're going backwards. So we're saying, what would GDP, real GDP, have had to have been in 2002 such that if we grew at a rate of 1.33, we arrive at a GDP of $292 in 2003. So to summarize here, we first figure out what the growth rate is using our formula from above. And then we use that growth rate to calculate real GDP in whatever year's dollars by moving either ahead or backwards from the GDP of that year using our calculated growth rate.